Hi, welcome to another episode of Out of the Blue. I'm Blue. Happy 4th of July. Today we're talking about a pretty all-American thing, and that is wimps and machos. Not nachos, machos. I'm not talking about the toxic idea that we force on young boys that either you are hypermasculine or you're not really a man. I'm talking about a completely different dark matter altogether. If you don't know what dark matter is, then please watch this video over here. Dark matter is something that makes galaxies and things in the universe heavier than we think they should be based on the baryonic matter that we can see. Baryonic matter means it's composed of, like protons, neutrons, and electrons, the building blocks of everything. Dark matter makes up about 30% of what we see in the universe, and that's a lot more than the measly 2% that comes from baryonic matter. So what is dark matter? A leading theory is actually that dark matter is made up of something we call WIMPs. Now that is weakly interacting massive particles. Now I know that's kind of a strained acronym, but an even better acronym is MACHOs, and that is Massive Astrophysical Compact Halo Objects. That acronym was actually made specifically to counteract WIMPs, because, if you have WIMPs, you gotta have MACHOs. You have to have both. There are even more acronyms out there. There's like RAMBOs, which are robust accumulations of something or other. Astronomers have fun with their acronyms. I'm going to start off with machos because to me machos are a lot easier to explain. Now what machos are is, like I said, they're massive objects, which means they're really heavy, but they're really dense. So they're things that we can't see very well. They're not super huge. They're just little tiny things scattered about the halo of galaxies. Now machos can be things like black holes, which you can watch a video on here. They can be neutron stars. They can be even brown dwarfs. Basically anything that's really massive, really dense, but doesn't actually emit its own light. So like our sun, it emits its own light. There's a lot of ways that we detect light, but machos wouldn't provide much light for us to detect. We would only see it by it interfering with light from elsewhere in the galaxy. Machos are actually not very preferred. We don't actually think that they're a #1 cause of dark matter, and that's for a few reasons. One, we'd probably have detected more machos than we have because we can, see them in some way because they do interact with other light. We'd see lensing, we'd see, like curving around them, stuff like that, but we really haven't seen that. Another thing is that they'd be kinda lumpy, if our galaxy had a bunch of machos in it, a bunch of black holes just speckled about, then the mass distribution would be kinda wiggly. We'd see, a bunch of things because black holes and stuff like that are kind of like points of mass, and we don't really see that. We see more of a smooth mass distribution, which wouldn't happen if all of the mass came from black holes. So now on to WIMPs, which are a little harder to understand. I personally don't understand them completely. WIMPs are theorized to be left over from the Big Bang. So we think it came from like nucleosynthesis, just particles that were left over that interact with the weak nuclear force and interact with gravity, but don't interact with light, which is kind of the main problem with dark matter, is that we don't think it interacts with light, therefore we can't detect it. Well, we're working on detecting WIMPs because we think it's a really strong candidate for dark matter, and we've set up ways to detect it directly and indirectly, and neither of them have provided any real results. Directly, we've set up like giant pools of water underground because we expect WIMPs to come through and interact with the water. It doesn't really do that. It hasn't done that yet. We've also set up tests indirectly, such as at the Large Hadron Collider, to see if we can get WIMPs to annihilate and then detect what comes off of them. And if we detect stuff that comes out of a WIMP annihilation, we can, infer that a WIMP annihilation happened, and obviously they exist. But no WIMPs have annihilated each other yet, for sure. Although, that'd be pretty cool, right? WIMP fight. Anyway, so WIMPs, although there's a stronger candidate than machos, we still don't have any direct observations of them. Probably the biggest reason that we're so hopeful about WIMPs is that we've calculated the radius, the cross-sectional area that it would take for them to annihilate, and it actually matches what the standard model of physics says should exist for this new type of particle that we haven't discovered yet. So scientists were thinking, these two models, they actually, they fit. It was called the WIMP miracle that these numbers matched. It's pretty cool. And we thought, if they fit, then there's probably this particle, and it's probably what's responsible for dark matter, which is a huge unknown thing, and we're really hoping that we can figure it out. But like I said, haven't figured it out yet. We still don't know if WIMPs are true. We still don't know if machos are vaguely correct. Our responsibility to get working on it and figure out if WIMPs are responsible, if machos are responsible, if there's some other thing responsible. Maybe someday you can come up with your own convoluted acronym. I think mine would be like baryonic light underestimating entity. Yeah, that's cool, right? Yeah. Alright, well, keep living science, keep thinking of strange acronyms. I don't know what you do in your spare time, and I will see you next week. Bye!